G'day, and welcome to part 4 of the do-it-yourself plasma table build. In this video, I go ahead and aligned all of the trucks. I install a cable chain. I install the end stops. I've 3D printed a holder for the Arduino. Yeah, basically I got it all set up, and we have a little test video at the end. So stay tuned. Here I attach the cable chain to the trucks. I install a piece of angle iron to use as a cable chain guide. This will help keep the cable chain in place and run smoothly. Time to install the end stops. I have to go ahead and bore out the holes because they were printed a little too small for the screws that I have. Time to install the properly fitted piece of angle iron. Here I begin to prep for the Z-axis. I begin running the wire. I decide to run the Z-axis along with the X-axis wires. Once again attaching the cable chain to the truck. Label all the wires so that I can go ahead and reconnect it later, as well as I start connecting all the motors. Here I attempt to install the core. It's apparent that I printed the wrong core. This sucks. So I apparently printed the core wrong, as well as all of these clamps, and because of it, it's not holding it in place properly. So that's going to take about 4 or so days to print all of these parts over again. So, based on that, I'm just going to go ahead and test out the without it, and this will be the focus of the next video. We are at 11 hours in, and we're only at 22% for the core. And this is where we're at. For my test, what I've decided to do is just get my Grant Fab logo. I am running it in Cura, which is a 3D printing software to make G-code for 3D printing. I'm just using this as a test. And what I'm going to do is I set it up so that it would just do the outline only. So as you see, it'll go ahead and do just the outline. and it says that it's going to take about 19 minutes total time to do. So I'm going to bring that over to the printer or to the plasma table, and we'll try it out. You'll see that the size, if I kind of zoom in, 465 millimeters on the x-axis, 276 on the y. So it is a fairly large print. Let's see how it turns out. Actually, I had to make some adjustments. I realized that the it was because it was set up as a print. It was building multiple layers high. So I went ahead and adjusted it so that it's just one layer height, and now it's down to 5 minutes. So we're going to go ahead and record it and see if the table moves in the right direction. So for this test, what I'm doing is, because I don't have the Z-axis done yet, I don't have the core installed, I just ran a motor by itself and the end stop by itself. That way there I can continue with the test. So what I'm going to do is I'm going to do my design. I'm going to pretend as if it's printing it. Right now it's homing the x-axis, and now it's homing the y-axis. This is the core. Now it's trying to home the Z-axis, so I will trick it. What you're going to do is imagine in this spot right here that this is where the core is sitting. One thing to take note of is that I can adjust the speeds so I can make it faster or slower depending on how well the plasma cuts. So that'll do it for today's video. Why don't you go ahead and subscribe and stay tuned, and we'll go ahead and finish up the Z-axis on the next one. Thanks.